Okay, everybody, welcome to the Lightbits SoftNet webinar on building data storage for the future. We're going to kick this off now. I am your moderator, Chip Ernst, and I am introducing our speakers today, which will be Kush Hathi from SoftNet Solutions. He's the founder and CEO, and Josh Goldenhar, the VP of Product of Lightbits. So welcome to the webinar. We'll have some polls throughout this. So if you wouldn't mind, please tell us what you think when you see our poll questions, and go ahead and enter any questions you have in the Q&A section, although we will hold responses until the end. But you're welcome to add your questions, and we'll get to that towards the end of the session. Thanks very much. Over to you, Kush.
Thank you very much, Chip, for the introduction, and thank you again, everyone, for joining today. As a value-added partner of Lightbits, we're excited to have Lightbits share an overview of how their technology is helping build data storage for the future with easy cloud native storage. Before we have Josh present, I wanted to take the opportunity for a few moments to introduce SoftNet Solutions and our offerings. SoftNet Solutions was founded in 1994 by a team of motivated technology professionals with a strong passion for solving complex business challenges by implementing innovative, cost-effective technology strategies. We pride ourselves in having over 25 years of experience in building industry-wide relationships with companies like Lightbits and other complementary manufacturers such as Supermicro, HPE, and Dell. Throughout our tenure, we've assisted organizations deploy and manage solutions globally, having worked across multiple industries such as retail, high-tech manufacturing, insurance, and local governments. We always focus on our customers and vendors to create long-lasting relationships that continue to grow. At SoftNet, we've always put our customers' needs and requirements first, making sure our partners understand this and work within our framework. We recognize that customers not only invest in the technology solutions that we offer, but in the people that we have within our team. SoftNet considers it an honor that our customers leverage our team as an extension of their own, even in today's world where access for employees to office facilities and data centers is limited. Our clients depend on SoftNet resources to keep their operations running. It's a great deal of responsibility and testament to allow vendors badged access to their facilities as an essential part of their workforce. We hold ourselves to a high level of honesty, integrity, and trust to maintain these privileges. While many companies say they can do it all, we really focus on a key set of offerings and leverage our experience and certified staff to help implement these. These cover things like enterprise infrastructure. This would include things like servers, storage like Lightbits, and networking, data center automation, working with technologies like OpenShift, Kubernetes, and insights on technology, AI and ML technologies, leveraging optimized hardware from companies like NVIDIA, workplace modernization, helping organizations with tools to be more innovative, and improving new world workflows and security. And of course, cloud operations, optimizing cloud value with monitoring services, governance, and security. So how we engage. We really, our certified team of professionals will work with your lines of business and your IT to create what we call solution blueprints that address the requirements we're solving for. We work as a liaison between all the different OEM partners, such as Lightbits, with a deployment on Supermicro, integrated in an APC rack. We touch every detail, both technically and logistically, to ensure the solution is deployed successfully. Once we have the appropriate solution architected, SoftNet manages the procurement and supply chain process of all the components, as well as the human resources to build and deploy effectively. Our integration area provides the ideal facility for performing stress tests, specific image loads, custom configuration settings to help eliminate any hardware challenges once the platform is on site. And as I mentioned previously, we also offer our clients the ability of having SoftNet remotely manage the turnkey platform, both remotely and on site. I wanted to highlight a few of our strategic partners in our ecosystem. And again, SoftNet really strives to attain the highest level of accreditation with these partners so that we can better help our customers. So in summary, SoftNet Solutions is an enterprise IT solution provider that puts our customers first and is focused on architecting, building, and helping with advanced technologies and services. I'd like to throw up our first poll question now. What type, and we'll give you about 30 seconds to go ahead and respond to that, and I'll go ahead and turn the reins over to Josh. Thank you.
Thank you, Kush. A few more seconds here and we'll close up the poll. So anyone with a vote or an opinion, please click off your multiple choice boxes and we'll let you know what we gathered here. All right, we've got the results there in. Looks like the SATA SSD is the most common out there with 38%. And yeah, number 2 runner-up is the SAS SSD. Interesting figures. We'll send out a summary with some of these results after the call today, but thanks for replying to the first poll. Handing over to Josh Goldenhar.
Well, hi there, Chip and Kush. Thanks very much. Very happy to be partnering with SoftNet and happy to really drive home, the idea that you pick the best software, you pick the hardware of your choice, and you have a very talented integrator to help you put these together and make a total solution. I'm Josh Goldenhar, the VP of Products for Lightbits Labs, and we're going to tell you a bit about how you can have cloud-native storage made easy and really build for modern infrastructure. Oh, that is, if we can ever get this to work right. So if you're doing cloud native applications, you may have a legacy environment, but we know a lot of folks are moving toward cloud native. And what we really mean there, let's just say it, we're talking about containers. If you're moving over to a containerized environment, you're going for cloud native practices. You want to get the efficiencies of hyperscalers. You want to move to modern applications. Just some of them are listed here. Things like different databases, analytics, maybe you're running Apache Kafka. And all of these things need low latency and high bandwidth. So they suggest using local flash storage. And you kind of get this sense of security that it's okay to use local flash because the applications themselves are going to go ahead and do the data protection. But this comes with actually some trade-offs that are not really great. So you do get really great performance locally, but generally because you have to pick a physical drive and put it in every single server, you get overall poor utilization. And your recoveries are always going to be, that is recovery against a server failure or just a drive failure. Your recovery is always going to be over the network. So this is going to really impact your network. And lastly, this actually breaks with the philosophy of Kubernetes, which is application portability. And we don't mean portability like from different system to system. We need physical portability. That is, applications are not tied to a physical server. If you use a local drive, well, you're kind of tied to that server. Even if you move somewhere else, you're going to have to do recovery over the network. So it really doesn't go along with Kubernetes philosophy either. And when I say underutilization, I mean massively underutilized. We find in surveys on a regular basis that folks are usually around 20% utilized for capacity. We've seen as low as 5, and people who are doing really well are up to 50. But that still means you've paid for a lot of capacity that you're just simply not making use of, which is wasted money. And people don't think of the other fact that NVMe drives, if you're using local NVMe flash, are really high performance. They can be 600,000 IOPS in a single drive, and it's very difficult for the total amount of applications on any one server to drive beyond like 300,000 IOPS. So you're also wasting about 50% of your performance. So by putting local drives in, you do get very good response time local, but you waste a ton of capacity and lots of performance. So you really want to fix that, optimize for that. So this is what it looks like if you go ahead and use Lightbits Labs LightOS. Lightbits is the company, LightOS is our software product. And I'm going to kill whoever keeps moving the slides. Lightbits is the company, LightOS is the software. And you can see that our goal here is to go ahead and use dedicated storage servers with NVMe flash you put our software on, and it makes it into a virtual all-flash array. Now you're completely disaggregated from your applications. You still get local flash block performance. So you still get the performance of local flash, but because you have a shared pool, you can get very, very high utilization, and you can really use all the performance and capacity that you paid for. Furthermore, applications are unaffected by drive failures because we take care of drive failures inside the storage servers. So your applications never see them, which also means that a drive failure does not result in a complete rebuild of a large drive over the network. So it keeps your network much better utilized and definitely not overtaxing your network. All volumes are also thin provision. So if you allocate an 8 terabyte volume, but you're only using 2 terabytes of storage, well, you're not using up all that capacity. It's not reserved. We know that if you're running an internal IT shop and people ask for a certain size volume, very often they ask for more than they need and they don't use the full thing. So with thin provisioning, you go ahead and you don't use flash except for what's actually written. And lastly, this is still HA. So we guard against server failures. And because it's all in the network, on a server failure for application servers, you can restart that application anywhere, attach the existing volume, and there's no resynchronization. So recovery goes, instead of minutes or maybe even hours, down to seconds. So this all gives you higher uptime and increased service level availability. So what is the main value of LightBits LightOS? It's still high bandwidth, high IOPS, and low latency. So it's very, very high performance, low latency, great for databases, great for anything that's transactional. It runs on standard TCP/IP networks, so it's very flexible. You use standard servers, standard networking, standard NICs. We're not asking you to replace your Ethernet adapters, nor change your configuration practices. It still comes with rich data services like proprietary arrays, which we'll talk about. You can configure the systems exactly to your needs if you want to optimize for capacity or performance or somewhere in the middle. And we're optimized for QLC media. So what that means is basically QLC today is the most affordable flash. So if you want to go ahead and use that most affordable flash, but you're worried about wearing it out or the fact that it doesn't have very high write performance, we correct both of those conditions. And we'll talk about that in the future. And this also gives you improved flash utilization because you have a shared pool. So you can get as close to basically 100% utilization as you care to. And lastly, you can scale storage independently. This is what it looks like when you go ahead and deploy. So you have your application servers on the left, standard Ethernet networks. You have your dedicated servers on the right, which can be of your choosing. So we know SoftNet offers different vendors for servers of your choice. And it's a clustered solution. So LightOS starts with a minimum of 3 servers, but can go as high as 16 in a single cluster. And this can literally give you tens of petabytes of usable space, depending on the drives you pick. So you're going to get petabytes of storage available in a highly available fashion. You can start small and you can grow. So that is, you can scale up on individual servers. You can go ahead and start with a smaller number of drives, and you can add drives at any time. And our elastic RAID protection, that was protection against drive failures, automatically expands online when you put a new drive in. So if you want to start a server with 8 drives, and over time, go to 9, 10, 11, et cetera, all the way up to 24 in a 2U24. You can do that. You can grow 1 drive at a time, or you could go ahead and add 10 drives all at once. Very easy to scale up individual servers, but you can also, for more overall performance, you can scale out. So if you start with a small cluster, 3 nodes, and over time, you can add a node at a time. And as you add nodes, the cluster will rebalance itself, and you'll end up getting much more capacity and more overall performance. So we're both a scale up and a scale out solution. As mentioned earlier, we're completely standards based. So NVMe over TCP is NVMe over Fabrics. NVMe over Fabrics is different flavors. We speak the TCP/IP flavor or protocol. And what that does for you is it means you can use any NIC of your choice. You could run on old servers with a 1 gigabit NIC if you wanted to, or you can run the latest 100 gigabit or even 200 gigabit. But the key there is that we're not going to force you to buy network interface cards from any one vendor. You get a choice of Linux kernels. It's available on various distributions. And it still supports features that you're used to in proprietary solutions or things like iSCSI or Fiber Channel, et cetera. That is multipath. So NVMe has its own version of multipath called asymmetric namespace access, call it what you like, it's still multipath. It means that there are multiple paths to a given volume. And if that server goes offline, that's serving that volume will automatically fail over, completely seamless. No configuration is needed on the clients. And additionally, you can also use practices that you're familiar with. So if in your environment, you're used to doing TCP/IP port bonding, that still works. So you can use port bonding on the clients, you can use MLAG on your switches. The key thing is because we use TCP/IP, there's nothing new to learn. If you know how to do your networking with TCP/IP, you can turn that into a storage network. And it can be a dedicated network or you can have a shared network. So it's all up to you. And I did mention earlier, we still have rich data services. So even though we're software defined, you're not giving up features that you're used to in proprietary arrays. I touched on the fact that all volumes are thin provision. We also support line rate compression that's configurable on a per volume basis. You set the data protection per volume. So you can either have a single copy, which is ephemeral, meaning that if a server goes down on one of our target servers, you're offline. Or you can have 2x copy or 3x. Now, most of our customers run 2x copy, and they have high availability against both a target server failure and they protect against drive failures on all the hosts. So this gives you a very high levels of nines, high durability. You, of course, can also expand volumes on the fly. And we also have snaps and clones. So if you want to go ahead and take snapshots for backups or for DevOps abilities and go ahead and clone snapshots, you can do all that, and everything is thin provision. So of course, this means snapshots and clones finish very, very fast in a matter of seconds. And they don't use any additional space until those clones or snapshots start to diverge from the parent. And when I said high performance, I'm talking very, very high performance, basically, essentially like local response times for flash. We're about 200 microseconds under load for reads and 300 microseconds for writes. And a single target server, depending on how you configure it, can go as high as 3 million plus random read 4K IOPS. So in a cluster, it's possible at our max cluster size with the best configuration to get nearly 50 million random read 4K IOPS. So there's no shortage of performance here. Of course, none of this would be any good if we weren't deploying in modern, cloud native fashion, and that is with failure domains. So what's pictured here is a single cluster spread across 3 racks. And we tag our servers, or you tag them when they're installed, or SoftNet would tag them for you if you have their services. And we split the replicas that are the basis for our high availability across the different domains. So if you can imagine domain A, B, and C here are 3 different racks. If you do a 2x replicated volume, we'll automatically make sure we split that over either AB, BC, or AC. And this way you can have an entire rack fail and your volumes stay online. And of course, this is not limited to racks. You could do this to rows in the data center. You could do it to different power zones, like if you had AB power. So it's up to you as the human here to split the failure domains in what makes the most sense for you. And of course, if you are running something like Kubernetes, you can map this to your availability zones. I did touch on the fact that we're also very cost conscious. We want to help you get the lowest TCO. And we touched on the fact that you can use QLC NAND. So QLC is currently the most affordable NAND. It has very, very good read performance, but its write performance is not nearly as good as previous generations of NAND. And additionally, you can wear it out very fast if you don't write to it, quote unquote, the right way. And what that means is that its endurance level is low. Now, this is why you don't want to use QLC in a local server, because if you can't control the way the application writes, and it's doing a lot of 4K random writes, you're going to wear that flash out very quickly. Well, the good news is that LightOS always completes all writes in a non-volatile write buffer in your standard off-the-shelf servers, and then we play out these writes in sequential order and in large blocks to the NAND media. This is exactly the way QLC NAND wants to be treated, and it means that we're going to make your QLC NAND last up to 5 times longer. And we're also going to improve its write performance because we're always writing to it in a sequential fashion. QLC NAND writes better in a sequential fashion than random. So these things together mean you're going to get better performance and longer life, meaning that if you want to, you can use these very high capacity drives and really drive down your total cost of ownership. So now we're coming to another poll. This is the customer participation phase. And this one is, where do you keep your data? Where is your data stored? Let's go ahead and pop that up. Give you about 30 seconds here. And if you guys want to just do the customer participation part and tell us, where are you storing your data? Is it on premises, in the cloud, a hybrid, or maybe some of you are all ephemeral and you don't store any data? All right, give it about another 5 more seconds. And we will continue. All right, so you can see some of the results there. Looks like a lot of you are doing hybrid. So that's very, very interesting. On premises and in the cloud is about, roughly equal. And very surprising, actually, that some of you are saying you don't really store any data. It's all ephemeral. So very, very good. So now the next portion is, what is this good for? What are you going to put all the solution for together? What are we talking about as far as modern? So we're talking about cloud native databases and analytics. This is really what you can speed up with LightOS. So there are many, many choices. They're not limited to this list. Of course, it's anything that's highly transactional or needs high bandwidth or a combination of both, because NVMe over Fabrics and NVMe over TCP is really good at handling both large block IO and small block. So if you're running any of these items here or related ones, probably a good fit for you to go ahead on premises to go ahead and have a very high performance storage that's not proprietary. It's going to cost you about half the price of proprietary all flash arrays, even at the same usable capacities. And then why would you want to do this? Well, oftentimes, we mentioned earlier that these kind of databases can go ahead and they can do the data protection themselves. So what if you have, though, multiple single instance databases? That is, what if you're running internally a service where you're running MongoDB or something like Cassandra? But for the database, you only need the performance of a single server, but you don't want to lose that data. So you don't want to go ahead and have to launch a second instance for high availability, because that means you're using a lot of CPU on a second host just to get data protection, which you didn't need. So a lot of folks have this issue. If you want to go ahead and launch single instances of databases, but you want data protection, that's a great use case for LightOS. You don't need to scale the DB service. You just need to run a single instance of that, put it on our persistent storage. And then if that server were to fail, you can go ahead and restart that instance on a different server and attach the storage, and it'll pick up exactly where it left off. So you can run now your MongoDB or Cassandra, et cetera, on any server on the TCP/IP network, and you avoid wasted CPU cycles. You don't duplicate SSD resources. This means you also get much better utilization. And it really can make your system fly because it is performing basically at the same rate as local flash. And we talked about this one, just largely wasted. You can overcome that. The other one you say is, well, wait, hold on a second. I don't do that. I scale both for performance of the database and I kind of get data protection for free, but we'll say free like in quotes, like free beer. So you go ahead and you deploy your MongoDB or Cassandra, et cetera, and use its typical default 3x replication. This means you have a pretty high overhead for your storage. You are replicating 3 times, but you are getting scalability. But what it also means is you get good performance, but you're robbing your systems of CPU, because instead of just doing database processing, they're also doing a lot of replication. And especially in the case of a server failure or a drive failure, and that's either one. Remember, if a drive fails or a server fails, you're going to go into a rebuild mode. And that's going to tax your network a ton, and it's going to rob you of CPU resources. So you're going to be in a degraded mode on the existing servers. By using the shared storage, even if you do a shared storage with data protection, you may use a little more storage, but you're going to improve the performance of your database. Your databases are not going to be affected by a single drive failure or even a dual drive failure. And if you wanted to, you could also use us as ephemeral storage, where we would still guard against a drive failure, but you could use the same basic amount of overhead. You'd use your 3x replication on the MongoDB side, but you wouldn't have to ever rebuild due to a drive failure. So you wouldn't impact the network or the application network. So there are instances where even if your application does its own data protection, you might still want to consider centralized storage. I went ahead and talked about this, that we guard against then both drive or server failures. So we'll go ahead and skip past this. And in summary, for cloud native databases, this really ensures application portability. This means your applications are not tied to servers, like only the servers that have local flash. Or if you were trying to, even if you're running Ephemeral, you're tied to a single server that has that flash drive, and you're counting on the fact that it's not going to have a failure, or because it's Ephemeral, you didn't really need that. But we really make sure that we adhere to the philosophy of application portability. LightOS provides very scalable, high performance storage, so it fits into your automated API driven environment, performs like local flash. Drive failures are handled seamlessly, so your applications never see a drive failure. We can also enable compression. This is important, like in a database like Cassandra. Cassandra in memory will go ahead and do compression for you, but that means your database is actually using CPU cycles to do the compression. So you could turn off that compression and get a higher performance in your database and let the storage do the compression for you. Lastly, this lets you independently scale. You know, when's the last time you went to a server that only had a 4 terabyte drive? If you want to scale that, well, you either have to replace the drive or add another drive and then put them together. It's kind of a pain in the butt, I think is a technical term. So we allow you to scale your storage and compute completely separately, which is very, very convenient and aids in operation. And lastly, for database DevOps, because we support full snapshots and clones, you can go ahead and take any database, you can clone the volume, and you can immediately use that clone, and it'll perform just as fast as the parent. You can use that clone in another database for development, do your tests, and if it's good to go, you can go ahead and promote that clone to be your new master, or you can go ahead and just update the original parent. Multi-terabyte databases can be cloned essentially in seconds. And then if you want backups, you can use snapshots in a very traditional fashion to go ahead and do read-only snapshots for backups, with the ability to revert if you went ahead and did changes to the parent that you didn't like. So now time for you guys to, let's all wake up and do another poll, customer participation again. If you're running or considering running Kubernetes, I would like to know what type of Kubernetes management environments or distributions are you planning to use? Are you just going to go ahead and do it yourself and just run plain vanilla Kubernetes? Are you going to use Rancher? Are you going to use Google Anthos? Because a lot of you said you were hybrid. So let's go ahead and get that poll up. And tell us how you're considering running Kubernetes if you are. And we'll go ahead and give that about 30 seconds. I just think I need the Jeopardy music playing here. Are any fans out there? And we'll do about 10 more seconds. Let's go ahead and get that poll up. All right, and here we can see the results real quick. Hopefully this is interesting to you. Wow, very surprising. A lot of you are going to go it on your own and just integrate Kubernetes yourself, maybe potentially with your own multi-cluster management systems or integrate into a different kind of portal system. So very interesting. Almost a quarter of you are going to go ahead and run just plain Kubernetes with OpenShift coming in, and it looks like Azure also rating pretty highly along with VMware Tanzu. So very interesting. Again, we'll include these results for your own interest later on, and then we'll continue. So let's go ahead and talk about that with Kubernetes. We integrate with Kubernetes, of course, with the CSI plugin. So you can go ahead and run the same kind of databases or applications we talked about before. You just go ahead and put our plugin on your Kubernetes worker nodes, and then we directly fit into Kubernetes native provisioning practices. So as I mentioned earlier, this means we keep the philosophy of Kubernetes portability, meaning that the pods can move to any physical server because you're not tied to this. So you don't want to have just local drives. If you're using local persistent drives, local persistent drive, excuse me, you'd have very good performance, but you'd be tied to individual servers. So we can go ahead and overcome that. This is what it looks like. This is very similar, so we'll spend only about 5 seconds on this slide. You saw this earlier in the presentation. The difference is that these are Kubernetes worker nodes. And in addition to Kubernetes running there, we're also having the CSI driver. Otherwise, everything else is the same. So we won't go into really the differences there. And what this is going to give you is portability. You're going to keep the philosophy of Kubernetes portability, and that pods can move to any physical server as long as they're on the same TCP/IP network, because they can go ahead and access persistent volumes and make persistent volume claims over that network. So you're not tied to any physical hardware, but yet it's still going to perform like local NVMe. And as before, drive failures are handled seamlessly. So you don't have to worry about it if your application knows how to deal with a drive failure, because the application is never going to see it. We have compression, which is selectable on a per volume basis. And you get to scale independently. A lot of folks say, hey, hold on a second. With Kubernetes, I want you to be native Kubernetes storage. That is, I want your storage to run as a container. But what this means is that on your worker nodes, you have to dedicate CPU, memory, and drive resources to those containers, which means that if you're going to scale, you have to scale both together. And we enable this independent scaling of storage and separately for compute and worker nodes with Kubernetes, which really is a better way to go, because you can go ahead and just focus your worker nodes on the container workloads. You don't have to worry about storage being a noisy neighbor. And of course, we do support snapshots and clones via the CSI interface. So if your applications can make use of snaps and clones, you can go ahead and use that in Kubernetes. All right, no one more poll. Actually, there's 2 more, but we'll do another poll, make sure everybody's up and paying attention. So what application environments do you utilize? We're kind of suggesting here, we're talking about Kubernetes, but maybe you're saying like, well, I'm not on the Kubernetes. I'm not on the container train yet. So we're curious to go ahead and get from you folks, what application environments are you using? What's important to you? So again, about 30 seconds. We'll get this from you. Hopefully it'll be of interest, show some results. And we'll give this about another 10 seconds. All right. Go ahead. So our results there, looks like a fair amount running Linux on bare metal, but a ton of you are running VMware. So I have good news for you in the second half of this year. We'll kind of touch on that a little bit later. Some folks are running OpenStack, so you're the ones. Okay, want to know. We do also, not talking about OpenStack specifically in this presentation, but you should all know that we do also have a Cinder driver. So you can have an OpenStack environment with a Cinder driver and get all the same benefits that we've talked about of a dedicated storage solution for your OpenStack environment. And a lot of you are running Kubernetes. So very interesting. Hope you guys are enjoying the polls or finding this information at least interesting. And we'll go ahead and roll forward. And that is, what about legacy environments? So we asked you that question about what environments you have, because not everybody can jump into containers, or maybe you're jumping into containers, but you can't convert everything at once. You know, if you're still running SAS Analytics or Oracle or SAP or SAP HANA, you know, these are things you can't just necessarily move over to modern infrastructures. Maybe you still want to go ahead and continue using those, but reap the benefits of very, very high performance. So we're very happy to tell you that we also work with legacy environments. You don't have to move to OpenStack or Kubernetes to go ahead and use us. The difference is you don't have to deploy more Fiber Channel. So if you're running on Fiber Channel, you should be aware that 100 gigabit networking with Ethernet is about half the cost on a per port basis than Fiber Channel 32, while being 3 times the bandwidth and equivalent or better latency. So with NVMe over TCP on Ethernet networks, you're going to get better performance than Fiber Channel. You don't have to support your Fiber Channel network anymore. You can go ahead and grow this at a lower cost point. And that's, you can either do a dedicated Ethernet network, but if you don't want to do dedicated, you can do a converged network. That is both your data and storage on the same. So the choice is up to you. Even if you do a dedicated Ethernet network and kind of treat it like a SAN or NVMe over TCP, you'll still lower your cost of that storage network, we'll call it, by half, and you'll get 3 times the performance. So we work great with legacy applications that are on Linux, bare metal, or basically you could be running any operating system if you're in an OpenStack environment under KVM. You utilize the NVMe TCP over driver instead of Fiber Channel, or instead of iSCSI. If you were using an iSCSI environment and you're like, I love the convenience of iSCSI, I just wish it was faster. I wish it didn't top out at 95,000 or 100,000 IOPS on a 25 gigabit link. I wish I could get higher IOPS. I wish I had lower latency. We've got news for you. If you're running these same kind of networks, I'm showing you test results from running on 25 gigabit networking. The kind of mustard yellow colored line is iSCSI. Excuse me, the purple. Yes, the mustard yellow line is iSCSI. The purple lines are NVMe over TCP. These are on 25 gigabit networking with the same 2 servers, an application server talking to a dedicated iSCSI target. So we're using the open source iSCSI target, and you can see the results. And then we go ahead and we replace the iSCSI target with LightOS NVMe over TCP on the very same hardware. And you can see that you got way lower latency with LightOS, while at the same time getting more IOPS. So you can get up to 6 times more IOPS because of the very low overhead of the NVMe over TCP protocol versus iSCSI, and you can get to 4 times lower latency on the same hardware. So if you like the idea of iSCSI, you can go ahead and just switch protocols, and you can get much better performance even on your existing infrastructure. We go ahead and we integrate into, of course, we've been talking about Ethernet a lot, OpenStack, Kubernetes, OpenStack via the Cinder driver, Kubernetes via CSI. We don't even have a GUI. So we are meant for you to go ahead and automate with a CLI and a RESTful API. And for monitoring, you can use Prometheus. We provide a pre-configured Grafana dashboard, so you can see all the management of the system and how you're using it and what the load is, et cetera. So all this will fit into your environment of choice. And I will say, if folks are asking, well, wait a minute, in that poll, we said we're running VMware. Where is VMware? VMware today does not support NVMe over TCP, the protocol. Of course, we'd be very happy to support VMware, but we need the VMware hypervisor to support that. So we are very happy to tell you, without really revealing anything, that we plan on supporting VMware in the second half of this year. So stay tuned. If you have a VMware environment, everything we talked about, you'll be able to reap the benefits of that in the second half of this year. In the meantime, if you want to get started on other environments and start kicking the tires on bare metal, we encourage you to go ahead and do that. And we are reaching the end. So I'll just give you in summary, bring your own hardware, talk to SoftNet, use the hardware vendor of your choice, and you'll have get expertise from SoftNet in helping you choose what's going to be the best for you, the configuration of that hardware, what your expectations are for performance and capacity optimization. Our intelligent flash management within LightOS means you're going to get thin provisioning, compression, snaps and clones, data protection against drive failures and against server failures. And we're optimized for QLC, which means we can go to high capacities, but keep your costs low while still getting high performance. And all of this means you don't have to change your networking. So if you're happy with NVMe over TCP, that is on regular TCP/IP networks, we're going to get you very high performance without having to change out your infrastructure, without having to learn about an exotic protocol that you're not used to. We don't require you to make changes to configurations in your switches, nor do we require you add different NICs or start selecting a different NIC. So this runs on standard Ethernet NICs without any changes to the way you do your management today on your switches. And lastly, we're not putting proprietary software on. You may hear others make claims they have high performance block, but they make you add a proprietary block driver. And we're not doing any such thing. This is NVMe over TCP, which is a standard that we helped develop. It is available in distributions such as Red Hat, Ubuntu, Debian. So it is there. We certainly hope it will be on VMware in the near future. And you still get features like multipath, and everything is just standard and off the shelf. So you don't have to worry about using something proprietary. And with that, this is our last poll. And thank you all very much for attending this presentation today with us, LightBits and SoftNet. And the last question is, hopefully you've heard some interesting things. What kind of follow-up would you like? And go ahead and pop that up. You know, just tell us if you'd like more information, if you'd like a meeting, if, oh my God, I loved it, I'm ready to buy, send me a quote. Of course, that would be a wonderful thing to hear. Or we know, you know, some of you, hey, there were gift cards offered for, I think, the first 50 registered attendees who attended. That may be redundant. And you say, hey, I'm just here for the gift card. That's, you know what, that's okay. We hope you learned some interesting information, enjoyed the polls. So go ahead and tell us this. And we'll give it about another 10 seconds. And we're going to go ahead and move into the Q&A phase, because I do believe we have some questions. Are we going into the Q&A, Chip?
Yeah, here we go. We've got a question here about open source NVMe over Fabric solutions being available for free. Why would I choose LightOS?
That is a good question. You can, we actually helped develop and drove the NVMe over TCP protocol. If you use NVMe over TCP as a client or a target as part of the Linux kernel, we wrote that code and contributed it to kernel.org. But what that gives you is just a protocol. It's like saying iSCSI protocol. I don't mean it's the same performance, but it just gives you the ability to use storage remotely, but it does not give you any of the features that we offer in our target. That is protection against drive failures, so a RAID-like protection, HA across different hosts. You can go ahead and get SPDK, for instance, from Intel, which will give you an NVMe over TCP target, but it's not going to give you thin provisioning. It's not going to give you compression. It's not going to give you snapshots and clones. So we are a full-featured storage target. We're a storage solution rather than just being a protocol.
Okay. Here's another one right here. This is asking about, you covered the proprietary or lack of proprietary. They're asking, well, how does that work? What versions can I use this with? So my application servers can use LightOS storage.
So we have a compatibility matrix, which we're happy to provide. I encourage you to please contact us. It is available in like the latest in Red Hat 8. The driver is just there. In Ubuntu 20 and above, the driver is just there. In various versions of Debian, the NVMe over TCP driver is just there. If you are using an older distribution of Linux, we very happily provide either the source or we will compile for you NVMe over TCP drivers and backport them to older releases.
Okay, thank you. Now we have a question from Charu asking, what are our capacity needs? And I'm interpreting.
I'll interpret that also as I'm not sure. We don't need a. I don't know if this is asking if we need, but like what's the minimum amount of capacity, or if this is asking what the overhead is. But each server you need a minimum of 3 servers, and each of those servers to be a storage server needs a minimum of 8 drives. The capacity of the drives doesn't really matter to us. Best practice is to have the capacity be all the same type of drive. But even on different servers, you can have different numbers of drives, but you need to have a minimum of 8 drives per target server and a minimum of 3 servers. So at minimum, you need 24 drives to go ahead and start. And you're going to have a full HA system. And then Charlie is also asking, what are your performance requirements? The performance requirements depend on what you want to get out of the system. So we're using, we're very happy with our partnership with Intel, and we were part of the Ice Lake Intel announcement. So if you're using Ice Lake servers that have, very fast processors with higher core counts, you can use a 16-core processor, and you're going to get very good performance. You're probably going to get about the 2 million IOP range. Latency is going to be just as low. Of course, the higher you push the system, your latency goes up a little bit. But if you want to get that 3 million IOPS, you're going to have to bump up to probably to about a 32-core processor. So the performance requirements of the servers depend on how much performance, how many IOPS essentially, or bandwidth you want to get out of the system. And that goes to also to whether you need 1 NIC or 2 NICs. So your mileage may vary. We'd really encourage you to go ahead and contact SoftNet, and we can talk to you about the solutions, what your performance needs are. And this is exactly the reason you want to go ahead and use a great partner like SoftNet, is they have the expertise to size a server to your solution. And then, if it was not quite right, the great thing is that we can scale servers up, or we can scale out the cluster if you needed more performance or more capacity.
Okay, we have a question from Brian here asking, is this just utilizing TCP IP? How is it any better than iSCSI that uses TCP IP?
So I touched on this just a little bit earlier. Of course, iSCSI and NVMe over TCP are both utilizing TCP IP underneath. The difference is iSCSI is based on SCSI protocol. SCSI protocol is very, very chatty. Maybe you've heard people say that TCP IP is high overhead. Well, that's because it gives you, guaranteed delivery on an unreliable underlying fabric that is Ethernet. So TCP IP has some overhead associated with by itself, but iSCSI has a very, very large command set and is a very chatty protocol and is limited in the number of parallel operations it can do. So NVMe is a hyper optimized protocol for flash. And NVMe, of course, talking about the protocol, is what travels over the PCIe bus when you have NVMe drives locally. So when you do NVMe over fabric and NVMe over TCP, we're taking that very, very optimized, a low number of different calls, NVMe protocol, and we're sending it over TCP IP. So there's just a lot less chattiness. There's a lot less commands going over TCP IP, and this results in much, much lower latency. So if you're doing iSCSI, you can, if you have a hyper-tuned iSCSI with a very expensive server, you can do single transactions in the 400 to 500 microsecond range. But as soon as you put any load on the network, your latency is going to spike up probably over a millisecond. With NVMe over TCP, we're going to give you about 200 microsecond response time for reads, even on a loaded network, and about 300 microseconds for writes. So you're going to get much better performance because the NVMe protocol over TCP IP is much less chatty than the iSCSI protocol.
Okay.
So with that,
another question from Dan asking, can I utilize LightOS in a traditional enterprise environment, like where he's using fiber channel SANs today?
Yeah, and we did. Thanks, Dan, for that. We did cover that a bit. You can't use it on fiber channel. We're not we're not an NVMe over fiber channel solution, but you can definitely use it on legacy servers. So if your servers have 10 gig or 40 gig interfaces, they're not up to 25 and 100 yet, we'll very happily use 40 gigabit, or you can go ahead and do link aggregation. You could lag together several 10 gig ports, or maybe just 2 of them, and get 20 gigabit. If you think about that, if you have 2 10 gig Ethernet ports and you were using fiber channel 16, if you can lag together your 2 10s, you're going to get more bandwidth than your fiber channel 16, and you can still do an HA configuration. So you can absolutely use this on the legacy application. To the applications, we still just look like a block device. And if you're putting a file system on top of a block device, you do that exact same thing with NVMe over TCP. So we can very happily fit into legacy applications, including also if you're using a shared file system. So if you're using a shared file solution, such as IBM Spectrum Scale, AKA GPFS, or StorNext from Quantum, or Lustre, or any of the open source file systems, the point is, if they can use a block device, you can use LightOS.
All right, that's it for the current questions, unless anyone else wants to put one up on the board now. All right, thanks, Emmanuel. I'm glad you felt this was productive. We've got a lot of people thanking us for the quality of the content and that they learned a lot. Glad to hear it. We'll definitely have a recording of this available with some summary or the actual results of the polls that we put up on the presentation. So you can look forward to that. We will also be reviewing the list of attendees that showed up to make that cut on the first 50 that showed for the Amazon gift cards we announced. So that'll probably take us a few hours, maybe a day or so, and we'll send you information about how to get the Amazon card if you're one of those winners. And I don't see any new questions. So this will conclude the webinar today between SoftNet Solutions and LightBits Labs. Very happy we had your attention. Much appreciated. Look forward to seeing you on the next one. All the best, everybody.
Thanks, everybody.
Thank you, everybody.